Mr. Benjamin made mention of Pauline, who will be coming to talk to us. It's a special presentation on net zero transition.
So I'm Pauline Dumons, I'm coming from France, and I'm really glad receiving this invitation from the Kenya Sugar Board to present what we do. So my company is called Net Zero, a startup launched a few years ago, working specifically on biochar. And I would be explaining a little bit more about what we do, what has been our innovation journey, and how biochar can benefit for all players of the sugarcane industry, the farmers, the mill, and at the end of the day, creating a real circular economy locally. Thank you. So I wanted to start just to give you, before entering on the technical details of the biochar topic, just to give you an overview of what a startup can achieve. So we've been 2021, and currently we have already 5 industrial sites running in Cameroon and in Brazil. We've been actually keeping really tight our mission, which is bringing biochar at scale. So what was our real polar star was really to think how we can develop the best technology and the best system to bring biochar back in the soils, and more specifically in tropical soils. We've been backed by numerous investors, so they have been investing in net zero in the last 4 years, a little bit more than $40 million. And actually, we've been as well competing on international technology competition like X Prize, winning this type of competition. So when you put a lot of excellence and a lot of effort and commitment in what you do, you can really become a successful company. And we have been as well trying to really integrate the value chain in which we have been involved. So the coffee industry, for example, and the sugarcane value chain in Brazil, trying to really be close and develop partnership and a business model that is fitted for the people with whom we are working. We are not an equipment company, we are not a consultant, we are bringing a technology that has been designed to make the most of crop residues and bring it back to the field on the form of biochar. All that with all the stakeholders around, so the processors and the farmers. So now, what is biochar? You know a little bit more our mindset and spirit in a certain way. So we started on the intro, cane is a carbon sink. Yes, this is true. Cane is a carbon sink when it's growing. But after that, when it's processed and when bagasse is left, it's not anymore carbon sink. Actually, this is releasing all the carbon that was stored by the photosynthesis. So a process has been designed to be able to capture this carbon, which we call a pyrolysis process. This is a way to make really stable this carbon and a way to remove carbon from the atmosphere on a really high permanency. In 2018, the IPCC, so the International Climate Panel, have been recognizing the biochar as a way to capture and remove CO2 from the atmosphere. This was led as well to the development of climate finance, and you will understand why this is important on any industrial project to be able to be financing the technological development. Something really interesting as well. So I just put a few figures just to give you the sense of what can be achieved. From 10,000 tons of bagasse, you can basically remove from the atmosphere, capture 4,000 tons of CO2. And this, you just multiply with the tons of bagasse left here in Kenya, and you can imagine the impact that can be made. For the production of biochar, you can use a lot of different types of biomasses, but we have been assessing various types of biomass, especially the one from the sugarcane industry. We've been dealing with the trashes, we've been dealing with the bagasse, we've been dealing with lignin and so on. Actually, the bagasse appears to be one of the best ones to be pyrolyzed. It's still a technical challenge because this is high moisture content, highly volatile, but at the same time, it's a high carbon content. So we have been designing a technology to be able to pyrolyze at best this type of biomass. And then just here I put a really simple process. So basically, the first step of the process is really the kind of pre-processing. So here there is a lot of ways to deal with it, depending on the sugar mill process, actually. Then there is the pyrolysis. So the pyrolysis is a thermal process that is done in the case of industrial pyrolysis at high temperature, where you will actually heat without oxygen this biomass. And here you will have two reactions. The first reaction is you will have the concentration of the carbon on its solid form, and you have a production of a gas. So we will have some energy recovery possible from this process. So just to give you an idea, to produce a ton of biochar from bagasse, you will need 5 tons of dry bagasse, and from this ton of biochar, you can be able to generate 2 tons of carbon credits, just to give you a range of idea. So I wanted to give this point that I believe it's important. Biochar is not just a charcoal powder. Biochar is really a product, so it needs to comply with certain quality requirements, and as well some traceability on the way it's produced. When you look to biochar, you will have certain specificities that I will detail just after, but actually this point of understanding what is biochar and what is not is really important, because this is a product that we'll put back on the soils, so we need to control the quality of the product that is going back on the soils. On non-controlled non-industrial ways to produce biochar, you can have some pollutants and contaminants, so we need to be careful with that. In the same time, we need to really understand that the structure of the biochar, this high porosity, its cationic exchange capacity is based on the way it's produced. Biochar should really be seen as a product and not as a byproduct. It's a product that should be used for improvement of soils, for biochar-based fertilizer, for example, and we'll see later on how it can be done. And as well, should be seen as a kind of a way to monetize carbon finance and finance assets. So you will have understood that biochar can be a really interesting new approach for the sugarcane industry globally, not only for millers, as well for farmers. So biochar is solving several challenges of the industry and should be embedded on the global transformative approach of the industry. The first one is, of course, the climate global challenge with the decarbonization of the agri-value chains. You will have as well another one which is related to climate change. So already a lot of farmers are impacted by climate change. It can be with drought patterns, rain patterns that change. It can be with temperature changes and so on. And this is bringing much more resilience to the crops. So biochar is really playing this resilience tool and a sustainability approach for soils. You have as well all the thematic related to productivity. I will go a little bit more in detail on this point. Biochar is a real game changer for productivity. It's not replacing fertilizer, but whatever you put in the soil makes much more effect. And after that, it's bringing a solution for valorization of biomasses. So I've been visiting a few mills, and I've seen that here the bagasse is piling up, and it's really necessary to find a beneficial way. So energy cogeneration is one of it, but biochar can as well play this role. So by recovering biochar, you create a local soil amendment, local fertilizer, local biochar-based fertilizer, and in the same time, you can produce energy for mills. And the last point, it can be an interesting investment because we will need people to invest on those type of infrastructure. So biochar, I will not go into much agronomic details, but I know that we have a few agronomists and farmers here. What we need to understand, biochar look like a sponge. So I put a picture at the center, which is basically when you zoom and look at biochar, this charcoal-like powder, it's a high porosity. So this high porosity is really important. It's having a alkaline pH, and as well, it's having a surface area that is really important. This is what makes the difference between artisanal biochar and industrial biochar mainly. And what you will see here, just after, it's how it interacts. So when you look at it, your biochar will have several effects in the soil. First, on acidic soils, and this is where it performs the best, you will have a pH buffering effect. So when your soil is pH 4, pH 5, you can expect, when you bring a soil amendment, maybe a point of extra pH. And this is a long-lasting effect. Why is that? Because biochar will stay in the soil. It will not decay, or it will decay really slowly. And this is why this is as well considered as carbon removal. The second point is about, you've seen this porous structure. It's a good structure to retain all the nutrients. So you will bring some fertilization, organic or mineral fertilization, but most of it actually will never be really used by the plant. When you bring biochar, you make those nutrients available. Same as well for the water aspect, that would be encapsulating on the structure created by biochar. What is interesting as well to notice is that you have a better root development because this is giving structure to your soil. So those basically are the agronomic properties of biochar. And those impacts actually lead to the crop productivity. So of course, biochar should not be seen as a silver bullet. It should be embedded on a global approach for productivity with good agricultural practices. But it has been studied extensively on a wide variety of crops and contexts. And consistently, biochar is giving really interesting results by 25 to 35% of extra yield, especially on acidic soils. We've been, so this is more, so what you see on this part is a meta-analysis study. So this is compiling all the scientific analysis, agronomic studies done in biochar. And we have been as well doing more precise and more targeted agronomic trials on sugarcane. So actually those trials have been taking place in Brazil. So far we have around 10 different field trials experiments. We are starting to receive the first results. All those trials have been implemented with universities and agro-industrial players. And what we see constantly is that there is an impact on the yield, 15, 20, 40% sometimes. Not only on the biomass part, not only on the cane growth, but as well on the sugar content. So sugar content, you see small differences actually. You will have an increase on the juice quantity, but as well on the sugar content. And when you have been talking about quality-based price payment, I believe this is really interesting as well on this extent. I wanted to mention as well a few of my visits here. So I've been to Kesreti, that you probably know and probably visit sometimes. So they are doing a really interesting trials with biochar-based fertilizer. They have been testing several formulations of biochar with filter mud, with mineral fertilizer. And actually, this new formulation can be a way to have better yield and to replace existing fully mineral fertilization. So there is already trials ongoing. They have done greenhouse trial with really good results. And they would be publishing in a few months the result of 2 years of trial on the field. So I believe for Kenyan players and Kenyan farmers, it would be really interesting to know more about it. As well, on the discussion I had with several mills, I felt really this willingness to develop local inputs. So biochar can be a real important stone to do that, to be integrated, of course, with filter mud and other available nutrients locally. And so here it's just an example of the result I was just mentioning. So here in this picture, it's in Brazil, and you can clearly see how biochar treatment can develop the yield and the growth of the cane. Now I wanted to give you more about what we have done in terms of innovation. So you understood biochar, its properties, how it can be used. I'm happy to take any question after that on how you apply it and so on, but I would like to as well give you a few insights on which type of model we have developed to make biochar not only a nice small-scale initiative, but a real game changer for the industry. Here it's an example of integration. So basically, we have designed a modular system that can be integrated into sugar mills. The integration that makes the most sense is to have a biochar factory adjacent to the biomass feedstock, so the bagasse pile, for example. And you can as well think to energy integration. So I know this is one of the topics that is really important here in Kenya. So when you produce biochar, you produce energy. This energy, these really hot flue gases that are coming out that can be used on several ways. When you have distillery, it can be used to evaporation. When you do not have, it can be used for preheating of the juice, from drying of the bagasse. There is very many ways in which it can increase the energy efficiency of the mill. Here it's a picture of systems that we have designed. So here you see a containerized system. Actually, this is a really breakthrough technology. This is the one that have been awarded by the X Prize Award. It looks simple, but this is as well because it was designed to be simple. What led us here, it's a a three-stream approach should be easy to install because you will be installing it on an industrial existing site, so it's super compact. And it's pre-assembled. So you just need to, actually, the Net Zero team will come into your mill and install it, and commission it, and train the team. Then it's as well, it has been designed as well to actually be easy to operate, because as you will have understood, Net Zero will not sell a technology and run it for you. It's your operation, and it's your business. So this is why it has been thought as well with a strong digital backbone to have a maximum of remote control, alerting system, and so on. We have as well designing an offer, a service offer in terms of technical assistance to make sure that you get the most from your biochar factory. And the last point, and something that I wanted to mention as well, it's the ease of maintenance. It has been thought to be able to replace the spares easily and so on, so you would have high efficiency and high reliability of your equipment. So far, our plants are running with 90% of availability. So this is really something that can be fully integrated to stringent industrial routines. And we have been as well designing, so this is more about the innovation history as well, but we have been designing a full digital backbone. So being able to design the equipment, being able to get data on any point of the process, being able to have this digital measurement and verification system. We have been as well designing this system, partnering with the best in class, I would say. So Dassault system for the production systems, but as well Palantir, so the American firm that is actually supporting us on creating actually the structure that is hosting all the data and connecting all systems. This makes a lot of sense when you start to collaborate, because any company will have its own system, and the system we have been designing is designed for integration. So you will have to understand this is not only about hardware, this is software, this is as well knowledge. So we have been developing an offer to support installation and commissioning, technical support, agronomic knowledge. And at the end of the day as well as the sales of the carbon credits. Whatever we have bring in the table in terms of digitalization and traceability, this is the end game. If you want to have a profitable and sustainable project that produces biochar consistently, you need to be able to guarantee that you will sell your carbon credits over the long run, over the 15, 20 years of your operation. And this is why our system is designed for scale, and to scale with the market as well. Just a few conclusion insights. This is a biochar project should be seen as circular economy. This is climate, this is better soils, better yields for farmers, and this is as well energy for a mill. So everybody would benefit from such a project. And what is really important to start with a project is to start to think on how you can integrate it to industrial operation, but as well on the farming practices. So those are my last comments. I'm really happy to take any question.
All right, thank you so much. A big round of applause for Pauline. Thank you so much. Pauline, we just have a quick surprise, Kenyan surprise. Lennox and Bonamukabana, please join her at the front. It's simple. Now show us. How do you do? Kila mtu tusimame kidogo, tusimame. Just that. Pauline. Mabeka kidogo. Wewe. Benjamin, I can see you. Aya, zunguka kidogo. Pauline, that's how you do it. A big round of applause for Pauline. Thank you so much for Governor. Thank you so much, Lennox. Well done. Fantastic. Well done.